Are you preparing for a Java interview and wondering where to start? Welcome to what we believe is the world's best Java interview guide. This is packed with carefully selected questions, real code examples, and practical insights. I'm Ranga Karanam. I'm the founder of In 28 Minutes. With over 1 million learners across the world, I've helped thousands of developers master Java and succeed in their careers. I've conducted more than 100 technical interviews, and this guide is a direct result of that experience. It's designed to help you understand what really matters in interviews, from fundamentals to real world scenarios. And what's the best part? We have created a complete companion website with every single question and answer available at interview.in28minutes.com. You'll also find the link below in the comments. Whether you're brushing up for an interview or strengthening your Java skills, this guide is for you. So what are we waiting for? Let's get started with the Java interview guide. Welcome to this section on core Java. In this section, we'll be focusing on wrapper and string classes. We will learn why these classes are immutable and how memory optimization works for these classes. We will dive deeper into string handling. We will understand something called a string pool. We will look at intern method, and we'll also understand some of the best practices with respect to handling strings. We will also look at conditions and loops. We will discover best practices with writing clean and readable code. We'll also look at how you can work with arrays. We will explore effective ways to use and manipulate arrays. We will look at how Java improves readability and reduces noise with text blocks and type inference. We will also explore the new feature records in Java. We will learn how Java records simplify boilerplate and when to use records. Are you ready to dive deeper into all these concepts? I will see you in the next step. In this step, let's talk about why are wrapper classes needed. In Java, there are a number of wrapper classes like integer, double, float, and a lot of them. These are defined in a package called java.lang. And these represent wrappers around primitive data types. Int, double, float, all these are primitive data types in Java. And the integer class and the double class represent wrappers around these primitive data types. Why are they needed? Number one, they allow primitives to be used as objects in collections like ArrayList, and in generics, you need to use classes. You cannot store primitive values in a collection directly. So wrapper classes allows primitives to be stored as objects in collections. These wrapper classes also provide a number of utility methods. Integer.parseInt, double.valueOf. So it provides utility methods that help you to do conversion of these values also very easily. To make the conversions from and to primitive values very easy, wrapper classes also support auto-boxing and unboxing. Let's look at an example. So this is a simple example where we are making use of a wrapper class to store things into an integer. We cannot create a list as list of int. So this is not allowed. List of int is not allowed. That's why we created it as list of integer. Integer is the wrapper class in here. So we are creating a list of integer in here. We are using the diamond operator. We are not specifying integer in here. And we are adding the numbers into the list. Over here, we are adding a int value 10. How is it added to the list? Because of auto boxing. This 10 is auto-boxed. It's automatically converted from int to a integer, and it would be added to the list. Same happens with 20. Now, if I actually get the values and sum them up, for example, over here, what I'm doing is I'm getting numbers.get of 0 and numbers of get of 1, and I'm adding them and storing back into sum. Here, the opposite happens. The integer gets converted to int. This is called unboxing. So there are wide variety of wrapper classes in Java. These represent each of the primitive types. So byte, short, int, long, float, double, char, and boolean are the primitive types in Java. And the corresponding wrapper classes are byte with a capital B, short with a capital S, integer with a capital I, long with a capital L, float, capital F, and you also have double with a capital D, and char is represented by character, which are capital C, and boolean values are represented by boolean with a capital B. All these classes are defined in java.lang package. And these provide a number of utility methods as well. So if you want to convert a string into an integer object, you can say Integer.valueOf 100 and create a integer value. An alternative is also to use the parse int. You also have methods to compare two integers. Do they have the same value? You can convert an integer to binary string using toBinary string. You have similar methods for double as well. Value of, parse double. Is nan is not a number. For example, 0.0 divided by 0.0 is not a number. So you can find if something is not a number by using the is not a number function. There are also methods defined on the boolean wrapper class and also the character wrapper class. Boolean has value of and parse boolean methods, and character has is digit. So you can check if a character is a digit. You can convert a character to uppercase or to lowercase. So there are a lot of utility methods in these wrapper classes. So the key things to remember are autoboxing converts a primitive into a wrapper object automatically. So integer num is equal to 10. The int value is getting converted to an integer. Unboxing does the reverse. It converts a wrapper object back to primitive automatically. So int value is equal to num. So this num over here is an integer. This gets converted into an int value. This is unboxing. One of the important things is wrapper class objects cannot be modified after creation. They are immutable. Just like string values, wrapper classes are also immutable. In this step, we talked about why are wrapper classes needed. They allow primitives to be used as objects, and they provide a number of utility methods. Welcome back. In this step, let's talk about the best practices in using wrapper classes. Let's start with creating of wrapper objects. It's always better to use value of instead of new to create your wrapper classes. So it's better to use something like Integer.valueOf and pass in a number 10 or string 10. That is the best way to create wrapper classes because they use cached objects. A number of these integer values are cached in memory. We will see an implementation of it a little later, but this would reuse the cached objects in memory. What this would create in here, if you use a new integer, is it would create a new integer object. It does not use the cache. So there is unnecessary object creation here. So typically using value of is preferred to create wrapper objects rather than new. Next, very important thing is to understand autoboxing and unboxing. Autoboxing can create unnecessary objects leading to performance issues. If you have code like this, integer sum is equal to 0, for I is equal to 0, I less than 1000, I plus sum plus is equal to I. What we are doing is we are promoting this value, int value, to an integer and adding it to the integer value. And therefore, autoboxing occurs. Each time autoboxing occurs and a new value is created. As we discussed earlier, integer values are immutable. So what would happen here is that each addition would involve autoboxing as well as it would involve a creation of the new object. And that's why the recommended approach is to actually use int values. Int sum is equal to 0 and we are doing sum plus is equal to I. Over here, we are adding using int values. So there is no autoboxing or creation of objects in here. An even faster approach obviously is to use functional programming. We will go into depth into functional programming a little later in a future section, but this operation can also be done in an easier way by making use of functional programming. Let's move on to the next best practice. Next is use parse methods for string to primitive conversion. If you want to convert a string value to a primitive value, then the recommended approach is to use integer.parseInt. Do not use new integer of 1 to 3. Even though there is a constructor like this, do not use this because this is inefficient, because this would actually create an unnecessary object. In addition, this is also deprecated. If you want to convert string to primitives, this is the recommended approach. In this step, we talked about the best practices in using wrapper classes. In this step, let's talk about how does Java optimize memory usage with Integer.valueOf. Integer.valueOf caches commonly used integer values. Instead of creating a new object, it reuses an existing one from the cache when possible. Why does Java do that? To reduce memory usage. You would see that numbers like 1, 2, 3, 4, 5, like smaller numbers, are frequently used. You don't want to create unnecessary objects for all these numbers. So what Java tries to do is to reduce memory usage by avoiding unnecessary object creation for these frequently used values. This improves performance because cached objects are returned instead of allocating new memory. What does Java do? Java maintains a cache of integer objects from values -128 to 127. When integer.valueOf n is called within this range, it would return a cached object instead of creating a new one. If the number is outside the range, a new object is created. So you can see an example of it in here. I'm saying integer a is equal to integer.valueOf 100, integer b is equal to integer.valueOf 100. And both of them are got from the cache. And therefore, if you do a is equal to b, it would return a true back. However, if you are creating values greater than 127, so over here we looked at the range. So 127 is the maximum value which is cached. So if you are creating a value which is greater than 127, you would see that these two variables which are created, x and y, are not the same. They are equal, but they are not the same objects. So x is equal to y will return false back. Now you might be wondering, where is this cache defined? Java uses an internal cache which is defined in the integer class. So there is a class called integer class. You can see that this is implemented as private static class integer class. So this is a very good example of static inner class. So you are having integer cache which is present as a static inner class inside the integer class. And the code for the integer cache looks something like this. You have a cache array. This is a integer array. And what are we doing in this static block? We are creating an array of the right size. And then we are storing the values in there. So we are setting the values into the cache. And later on, when you make use of the value of method, the objects from the cache are what are returned. So this would ensure efficient memory usage for frequently used integers. And the important thing is this is not just applicable for integer class. There are cached values for most wrapper classes: byte, short, integer, long, character, boolean. For all these, there are cached values. Float and double, on the other hand, do not have any caching. In this step, we looked at how Java optimizes memory usage with methods like integer.valueOf. We saw that Java makes use of a cache for a number of wrapper classes, and therefore it reduces the amount of memory usage. In this step, let's talk about why wrapper classes in Java are immutable. What is immutability? Let's start with understanding that. Immutability means an object cannot be modified after it is created. Why is this advantageous? This helps you with thread safety. If the value of an object does not change, then the code is guaranteed to be thread safe. Another advantage is you can cache these values. You can reuse these values. And you can get predictable behavior. Immutable programming leads to predictable behavior. What happens with the immutable classes is if you try and make any modification, it would create a new object instead of changing the existing one. To start with, let's actually try and see what is involved in creating an immutable class. So here we are trying to create an immutable example as an immutable class. The first thing we are doing is final. This final prevents subclassing. We don't want anybody to extend an immutable class and change the behavior. And that's why we make it final. And the next thing is to make the fields private final. This means that there would not be any changes after initialization. So the value in here is private final, and therefore this value would not change after initialization. You set the value in the constructor, and after that it cannot change. The last thing we would do is to have no setter methods. Since this is a final int, we cannot have a setter method to modify the value. So this is how you can implement a simple immutable class. Now let's see the immutable behavior for wrapper classes. Wrapper classes like integer, double, boolean, etc. are immutable in Java. Why? Because this allows the caching mechanism to work. Frequently used values like Integer.valueOf 10 are reused. Values from -128 to 127 are cached, and when we look for these values, these objects are reused. This would reduce the memory usage. This also provides thread safety because threads cannot modify the shared values. The wrapper classes are immutable, so those values are not going to change. So let's look at a simple example. Of wrapper class immutability. If you have integer x is equal to 10 and you do x is equal to x plus 1, what would happen? This would actually create a new integer object. The existing object will remain the same. However, a new one is created, and over a period of time, the old one would be discarded away. So what would happen in the background when you do something like this? So we are creating an integer x is equal to 10. So what would happen is x would be created on the stack with a reference to this specific thing. So we would have 10. We are creating it as a wrapper. So this would be actually a integer 10. And this would be stored on a specific location, 1001. Now what are we doing in here? We are doing x is equal to x plus 1. So the x plus 1 would be calculated, which would be 11. And this 11 would be created as a new object. So this would be actually 11, which would be created on the heap. And we are assigning it back to x. So what would happen? X would be updated to have this memory location. So we'll have 1101 in here. So 1101 will be the value which would be stored in x. You can see that the existing integer value does not get changed. Whenever there's a change, a new object is created on the heap. The existing one does not get impacted at all. Another important thing to remember is that the values which we are making use of right now, 10 and 11, are small values, and therefore they are retrieved directly from the cache. In this step, we talked about the fact that immutability means that an object cannot be modified after it is created. Once an object is created, it will not be modified. Any modification would result in creation of a new object. We also talked about how you can create a simple immutable class in Java. You can make the class final, make the fields private final, initialize them in the constructor, and ensure that there are no setter methods changing those values. Typically, immutability is one of the approaches to achieve thread safety. Immutability also allows you to cache values, and also it provides a predictable behavior. Welcome back. In this step, let's talk about string versus StringBuffer versus StringBuilder. String is used for immutable data. If you are storing fixed values like constants, configuration keys, or error messages, string is a great way to store those values. Now, when is it recommended to use string classes? Fixed values that don't change. String is not recommended for frequent modifications. Why? Because if you modify a string, you are creating multiple objects. Just like wrapper classes, string is also immutable. Over here, we have greeting is equal to hello. So this hello is an object. And if you do greeting plus is equal to world, a new object hello world will be created. The existing object hello will remain as is. However, a new object hello world will be created. And that's why it is recommended to avoid string class for frequent modifications. If you have frequent modifications and you want to be thread safe, if you have multiple threads and if you are sharing a value among multiple threads, you want your code to be thread safe. In that kind of a scenario, you can use StringBuffer to make thread-safe modifications to your string values. So you can create a new StringBuffer and use the operations which are provided by StringBuffer to make the modifications. So you can use append or insert, or you can do a reverse. So there are a lot of operations which are supported by StringBuffer, which you can make use of to perform the modifications that are needed on the specific value. The great thing about the StringBuffer is that it is not immutable. So these operations in here change the value of the actual string buffer. They don't really create a new object. So when you have multi-threaded modifications, then you can go for StringBuffer. If your program runs in a single threaded environment, in that kind of a scenario, the recommended option is to go with StringBuilder. StringBuilder is a mutable string alternative optimized for performance. It is faster than StringBuffer because it's not synchronized. All the methods in StringBuffer class are synchronized. That means only one thread can execute any of the synchronized methods. When one thread is executing a synchronized methods, no thread is allowed to execute the other synchronized methods. They'll all be waiting. And that's why StringBuffer can be slow. StringBuffer provides you with thread safety, but it can be slow. If you're using a single threaded environment, probably you can use StringBuilder because you don't worry about thread safety. If you look at the methods which are provided by StringBuilder, they are very, very similar to the methods which are provided by StringBuffer. So if you want frequent modifications in single threaded programs, it's recommended to use StringBuilder. However, it's not recommended to use StringBuilder in a multi-threaded environment because it's not thread safe. As we discussed earlier, it's very, very important to remember the performance issues that can arise if you are doing string concatenation in loops. If you write code like this, we are creating an empty result and we are appending 1000 values to it. This would create a lot of strings. It creates a new string object in every iteration. A better approach would be to use either StringBuilder or StringBuffer. If you want a thread-safe approach, you can go with StringBuffer. If you're not worried about thread safety, you can also use StringBuilder. So here is an example using StringBuilder. So we are creating a new StringBuilder object and we are appending I to the StringBuilder. So let's quickly compare string versus StringBuffer versus StringBuilder. String is immutable. However, StringBuffer and StringBuilder are not immutable. When it comes to thread safety, string is thread safe because it is immutable. StringBuffer is thread safe because all methods are synchronized. StringBuilder, on the other hand, is not thread safe. When it comes to performance, string is the slowest because each concatenation, each operation you would perform would result in a new string being created. StringBuffer can be slower because of synchronization. StringBuilder would be the fastest way to achieve string concatenation in a single threaded application. Whenever you do a frequent change with respect to string, it would create new objects. StringBuffer provides thread safety for your changes. However, if you are concerned about performance and not about thread safety, then you can use StringBuilder. In this step, we looked at a comparison between string versus StringBuffer versus StringBuilder. Why are string classes in Java immutable? The string class in Java is immutable, meaning its value cannot be changed after creation. Why? Number one, security. Strings are used in class loading, networking, and they might be used for security keys. If they are mutable, an attacker could change the password to something else. So in memory, if the value is changed, then this can cause security issues. Another reason is thread safety. There would be a lot of string values that are created as part of your program. And if you want to provide thread safety to all of them, it might become really, really complex. Because string values are immutable, they can be shared safely across threads. The other reason is string pooling optimization. Because string values are immutable, they can be pooled. So you can have multiple references to the same string in the pool. We reuse the same object and we save memory. Let's look at a simple example of string immutability. So if you create a string like hello and you concatenate hello and you concatenate world to it, this would actually create a new object. The existing string hello would remain as is. So what would happen is s.concat creates a new string, but the old string s would still be pointing to hello. If you want, you can say string s1 is equal to s.concat, and then you would have the new value in s1. In this step, we talked about the fact that string classes in Java are immutable. In this step, let's look at another new feature which is introduced into Java, text blocks. So here is an example if you're not making use of text blocks. So we would want to store a JSON. So it has name John, age 30, and we would want to store it as JSON. So you can see how complex it is to create something like this. However, if you're making use of text blocks, it's as simple as that. You have three double quotes here. So starts with three double quotes, ends with three double quotes, and between you can write whatever you would want. This would be stored along with the formatting that you have in here. So text blocks simplify writing complex string values as part of your code. This is a new feature which was introduced in JDK 15. So you don't need to worry about /n or escaping double quotes for multi-line strings. This code is much more readable because the code looks like actual text formatting. Text blocks also provide you with auto alignment. They handle indentation automatically. So if you're creating JSON objects, or if you are writing HTML or writing a SQL, using text blocks would help you to keep your code readable. In this step, we talked about text blocks. You don't need to worry about escape sequences and write readable JSON, HTML, or SQL by making use of text blocks. In this step, let's talk about what is a string pool. String pool is a special memory area in the heap where string literals are stored only once. Each string literal, specific one, is stored once. All these string literals are stored in a special memory area called the string pool. Why? Because the goal of the string pool is to save memory by reusing the same string objects. Instead of creating duplicate string values, we would reuse the same objects. When you create a new string using double quotes, for example, between double quotes you have a value hello. It is automatically looked up against the pool. If it does not exist in the pool, it is added to the pool. If the same string already exists, Java reuses the existing reference instead of creating a new object. So let's look at an example. So over here in the program, both S1 and S2 refer to the same value Java, and we are creating it as a string literal. So when we are creating S1, Java would be stored in the string pool. When we are trying to create S2, Java would identify that this value is already in the pool, so it reuses the same object. So if you do S1 is equal to S2, then you would see that the output is true because they are pointing to the same object. It's very, very important to remember that we are comparing references here. We are not saying S1 dot equals or equals ignore case S2. What we are comparing is S1 is equal to S2. This would only check the references. It will not check the actual values. So you can see that over here, we are reusing the same object. Now, one thing you need to remember is that it is not recommended to use new string of hello to create a new string object. Why? Because it would create a new string object always in the heap memory, even if the same value exists in the pool. So what you will end up with is two objects, one in the heap and one in the pool. So if you're doing something like this, S1, S2, S3, you can see that we are using string literals for hello and hello here. However, we are using new string along with the string literal for S3. What this would do is this would create an additional object in the heap. And that's why you would see that S1 and S2 are pointing to the same object, same reference. However, S1 and S3 are different objects. We are using new string. So this is a new object which is created in the heap. So the best practice is to always prefer string literals to save memory and improve performance. In this step, we are talking about the string pool. String pool is a special area inside the heap where string literals are stored and reused. In this step, let's talk about the intern method on the string. What does the intern method do? It forces a string to be stored in a string pool even if it was created using new. It helps you to reduce duplicate objects and optimize memory. Let's look at a simple program. S1 is created using new string. Now let's say I want this object to be moved to the string pool. I don't want to store it on the heap. That's where you can call the intern method. So s1.intern method would move it to the string pool. And now if you create a new string literal hello and assign it to S3, you would see that S2 and S3 would be pointing to the same string on the string pool. So S1 is created outside the pool, but S1.intern would move it into the pool. S2 and S3 would now share the same reference, saving memory. So the intern method forces a string to be stored in a string pool even if it was created using new. This would help you to reduce duplicate objects and optimize memory. In this step, let's look at the things to be careful about when comparing strings. The first thing is using is equal to instead of equals. Is equal to compares references. It does not compare values. If you are interested in comparing the values, if you are looking at hello versus hello, then it's recommended to use equals. So string s1 is equal to hello, s2 is equal to new string of hello. If you do s1 is equal to s2, you are only comparing references. This would return false because these are different objects. However, s1.equals s2 would return true. Why? Because they have the same content. The content here is hello and here as well it's hello. If you want to do a case insensitive comparison, you can use equals ignore case. Equals is case sensitive, equals ignore case is case insensitive. So if you do a equals ignore case on hello and hello, you can see that here everything is small cap. Here you can see that everything is lowercase and here everything is uppercase. And you can still see that the output would be true because equals ignore case would ignore the case. It will only compare the characters. The next important thing that you need to be careful about is the fact that strings are stored on the string pool. String literals are stored on the string constant pool and can be shared. And therefore, it is recommended to use string literals created like this. It is not recommended to use new string because new string would create a new object on the heap. In this step, we are looking at some of the important things that you need to be careful about when comparing strings. We talked about the fact that equals is recommended to check content equality. And if you are not worried about the case, you can use equals ignore case. And also, whenever you're making use of strings, you should understand that string literals are stored in the string constant pool. And if you're using new string to create a new object, then if you are actually comparing the reference of the newly created object with an existing object in the pool, they would return a false back. Why? Because we are not reusing from the string constant pool if we are doing it using new string. We are creating a new object. So we are comparing different objects in here and therefore it would return a false back. I'm sure you're having a great time and I'll see you in the next step. In this step, let's look at some of the best practices with conditionals. Let's start with if. Instead of writing multiple if statements, it's recommended to use else if. So if age less than 18, else if age less than 60, else. So this kind of blocks are easier to read than having separate if conditions. Number 2, avoid complex conditions, or if you have complex conditions, try and improve the readability of them. Look at this specific piece of code. It's hard to read. This is very complex. So age greater than 18 and has license, age greater than 16 and has permit and has no violations. So what we are doing in here is we are trying to improve the readability. How can you do that? It's by creating specific variables with the right names. So I'm saying is adult with license, and I'm checking if it's the age is greater than 18 and has license. In that case, that's good. Is teen with permit. So if age is greater than 16 and has permit and has no violations. And the code becomes simpler if is adult with license or is teen with permit allowed to drive. You can see that by introducing meaningful variables, we made the complex condition simpler to read. And the next important best practice is to prefer ternary operator for simple cases. You can see that this piece of code looks little complex. If x is equal to 10, result is equal to high, else result is equal to low. Instead of that, you can use ternary operator. Result is equal to, so we are using the ternary operator, x greater than 10, question mark, high. If x is greater than 10, we are returning high back. Otherwise, we are making use of low. And another best practice is to use switch instead of multiple if else's when applicable. Switch these days is very, very simple to use. Switch expressions make it really, really easy. You don't even need to have break and things like that. So it becomes a cakewalk if you can write whatever you are trying to write with a switch expression. Over here, we are switching over a variable called day. And if it's Monday, Tuesday, you can add in all the other days in here. Then we are returning back workday. The default we are saying is weekend. You can see that this switch block is very, very easy to write. In this step, we looked at some of the best practices with respect to conditionals. We started with talking about using else if instead of multiple if statements. We talked about avoiding complex conditions. We talked about using ternary operator if it's possible. And also, we talked about preferring switch expressions when possible. I'm sure you are having a great time, and I'll see you in the next step. In this step, let's talk about the best practices with respect to loops. Let's look at the first one. Either use enhanced for loop or functional programming for collections. Why? Because these are faster and readable as well. You can see that if I do a int I is equal to 0, I less than list.size, I plus plus, and then print the values, this is little slow. Why? Because this is using index-based access, and we are also accessing the size method repeatedly. On the other hand, if you are making use of the enhanced for loop, this makes use of the iterator internally, and therefore this loop will be much faster. So for string item in list, we are doing a system.out.println item. An alternative is also to use functional programming. On the list, there is a for each method, and you can pass in the method you would want to execute. Here we would want to just do a system.out.println. So that's number one. Prefer using enhanced for loop, or you can also use functional programming. Next, avoid expensive operations inside the loop. Here the expensive operation that we are performing is list.size. If you have any expensive operations that you are performing in the loop, it is preferred to do it outside the loop. So what we are doing is storing size in a variable. So this is efficient because we are not repeating the same thing again. The same thing which we are trying to do in here can also be done using functional programming. We just need to say list.forEach, do the specific process. The next one is something which we already talked about, using StringBuilder instead of string for concatenation, especially inside loops. If you're using string, then concatenation creates a new object each time. And that's why you can use StringBuilder or StringBuffer based on the thread safety that you would want. The next best practice is to use break and continue wisely. Over here, even though the number matched, we are looping through all the elements. Instead of that, we can use the break. So once we have the match, then we can say it's found and break out of the loop. So this would exit the loop early. The next best practice is related to parallel streams. If you have huge lists that you would want to process, and if you are making use of a multi-core processor, then it might be useful to call parallel stream. This would enable your program to make use of the multi-core capabilities and do the operation in parallel. The last best practice is to choose the right loop type. If you have fixed number of iterations, for loop. If you have a condition that you keep checking until which you want to execute the loop, then while loop. If you are iterating over a collection, enhanced for loop or use functional programming. And if you are processing large data sets, you can make use of parallel stream. In this step, we looked at some of the best practices with loops. In this step, let's talk about the best practices with using arrays. If you want to print an array, if you print the array as is, it would print a hash code or something like this. It would not actually print the content of the array. If you want to print the content of the array, you can use arrays.toString. And if you have a multi-dimensional array, you can also make use of arrays.toDeepString. The next best practice is to use enhanced for loop or functional programming instead of the traditional for loop to loop around an array. So this is an example of the enhanced for loop to loop around the array and print the elements. And this is an example of using streams or functional programming to print everything inside the array. The next best practice is related to comparing arrays. If you want to compare two arrays, the method which is recommended is arrays.equals. This would compare the content of the arrays. If you compare arrays with is equal to, it only checks the references. It does not check the actual content. If you want to check two different arrays, if they have the same content, then the recommended one is arrays.equals. And if you have multi-dimensional arrays, then arrays.deepEquals is the recommended method. If you want to copy arrays, the recommended approach is array.copyOf. Array.copyOf would clone the entire array. So it would copy the entire array as is. You are saying I want to copy the original and I'm specifying the length of the original and we are creating a copy of it. You can also create a partial copy. So I can copy the first three elements as well. So array.copyOf original, 3. Or you can say I would want to create an array of length 7. So this is 5 elements. I want to create an array of length 7. That would mean that the last 2 digits would be filled with zeros, the default value. So array.copyOf creates a new array and it does not modify the original array. If you want to resize an array, arrays.copyOf might be a good way. So if you have an array of 5 elements and let's say you'd want to increase the number of elements or decrease the number of elements in it, then arrays.copyOf might be a good option to consider. Another interesting method is system.arrayCopy. One important thing to remember with system.arrayCopy is that the destination array should already exist. So destination array is an existing array. If you have two arrays and you want to copy, if you have two existing arrays and you want to copy values from one array to another array, in that kind of scenario, you can make use of system.arrayCopy. You can implement a loop. You can write a loop to copy all the values from one array to another array. But because system.arrayCopy uses a native implementation, it is faster. So if you want to copy hundreds of thousands of values from an array to another existing array, then system.arrayCopy might be a method you'd want to consider. Next best practice is to use list instead of arrays when possible. Absolutely. Lists make it easy to add and remove elements. And that's why, if it's possible, then always prefer using list instead of arrays. The last one is to use functional programming or streams for advanced array operations. Since Java 8, functional programming concepts have made Java really easy to program. It's always recommended to use functional programming and streams wherever possible. In this step, we looked at some of the best practices with using arrays. In earlier versions of Java before Java 10, for example, Java 8, Java 9, what you need to do is define the type of a variable in two places. For example, if you are creating an array list, you need to say, I'm creating a new array list, and also the variable type, you need to specify array list in here. How about not repeating array list of string again? How about using a var instead? And Java would actually recognize the variable type for you. Java would infer the local variable type. So Java would be identifying that numbers is of type array list of string even though you are just specifying var. This works with other classes as well. For example, new hash map. Now this var map's type would be inferred as hash map of integer comma string. Now what would be the advantage of something like this? Number one is less code. You are writing less code because you don't need to specify the type again. This reduces redundancy in variable declarations. Number two is improved readability. The focus is on the logic and not the type details. Number three, this is flexible. This works with generics, loops, and complex types. You can use these numbers with any of these things. Number four, compiler safety is still intact. Strong typing is still enforced at compile time. You cannot assign a value of a different type to numbers at a later point in time. In this step, we talked about a new feature in Java 10 called local variable type inference. Java would automatically infer the type by looking at the right hand side. You don't really need to define the type of the variable on the left hand side. I'm sure you're having a great time, and I'll see you in the next step. In this step, let's talk about records and how they improve the conciseness of Java code. Records eliminate boilerplate code. If you look at Java beans, we write a lot of boilerplate code. Once you have a few fields, you would create a constructor with those fields. You would have a number of getter methods, setter methods. All these is what is called boilerplate code. You would also need to implement toString method, equals method, hashcode method. You need to follow all the best practices related to them. So whenever we create a Java bean, we have a lot of boilerplate code. Records eliminate this boilerplate code and makes the code more readable and maintainable. Let's look at an example before records. So this is an example before records. So you have three fields in here. We are creating a constructor. We are writing the code for the constructor. We are creating getters. And in addition, we would need to implement equals, hashcode, toString. I have not provided the implementation in here, but this implementation would definitely run into multiple lines. You can see that creating a simple Java class called person with 3 attributes is pretty complex. And that's where records really help. Records make this code concise and readable. All that you need to do is to say public record person. You can specify the attributes within parentheses. And over here, we are having empty braces. Once you have code like this, you can do all these operations. You can create a new person passing in 3 values, name, email, and phone number. And you can also get you'll also get the toString method for free. So if you actually do system.out.println, it would print the actual values. There is also a getter method provided, person.name. Instead of person.getName, you can say person.name to get the name of the person. And also you can do person.email to get the email of the person as well. So the goal of records is to eliminate boilerplate code in Java beans by automatically creating a constructor, getters, and also you would get toString implementation, equals, and hashcode implementations for free. This makes the code more readable and maintainable. Welcome back. In this step, let's talk about the best practices with records. Number 1, use records for immutable data. If you have data transfer objects or configuration objects, you can create them very easily with records. Public record, name of the record, what attributes you want to have as part of the record. And over here, we are making use of empty body. You can also add custom validations in compact constructors. The body of the record does not need to be empty. You can add things like a compact constructor to enforce field constraints. For example, I would want to ensure that the name is not null and it's not blank. In that kind of scenario, I can write code like this. So you can see that we are saying public person, this is the syntax, and within that we are creating a block. So this block of code is automatically run during object creation. This would validate the name. If the name is null or blank, it would throw an exception. So you can add custom validations in compact constructors. This is what is called a compact constructor. You can also use methods. You can write methods You can create instance methods as part of your record. So over here, we are creating an area instance method. So in the body of the rectangle record, we are adding in an area method to return the area of the rectangle. You can also have static fields and methods as part of your record. So you can create static field like this, and you can have a static method returning the value back. However, it's very, very important to remember that records do not allow instance variables. You can have static fields, but instance variables are not allowed. In this step, we looked at some of the best practices with records. I'm sure you are having a great time, and I'll see you in the next step. In this step, let's look at what are the things that you should be careful about when using records. Number one, records are immutable. Fields cannot be changed after object creation of a record. So if you have a person P is equal to new person, you have created a value, you have created an object. After that, you cannot change the values of the object. You cannot say p.name is equal to Bob. This would give you a compilation error. If your class needs mutable state, if you should be able to change the value of a instance variable or something like that, then it's recommended to use a regular class. For example, if you're creating a bank account, the balance needs to be mutable. In that kind of scenario, it's recommended to use a regular class. The next thing is it cannot have instance variables. There cannot be instance variables in a record. All fields should be declared as part of the record header. You cannot have anything defined as part of the body. So you cannot add instance variables as part of the body of a record. Next, inheritance is not supported in records. All record classes automatically extend java.lang.record, and therefore they cannot extend any other classes. However, records can still implement interfaces. So a record can implement an interface. It can implement multiple interfaces as well, but you cannot extend any other class. So you cannot say employee extends person. This would give you an error if it's uncommented. So the recommended places where you can use records is when you want to create a data model, or when you want to store configurations, or when you want to create lightweight domain objects. If you want to create mutable objects, or if you want to have complex business logic, or if you want to create inheritance-based hierarchies, that's when you will not use records. For all these situations, it's better to go with regular Java classes. Now, before we end, let's look at a couple of good to know things about records. Java introduced this new feature called record pattern matching. Over here, we are looking at a simple example for record pattern matching. We have a course record with ID and name. What we are saying is object instance of course, and we are defining two variables in here, int ID and string name. If the object is instance of course, then what Java does is it would copy the values from the course directly into ID and name. You don't need to create a variable course in here and then say course.id and course.name. So this pattern matching instance of directly assigns the value to ID and name if this object is instance of course. And you can actually take this to the next level. So nested record pattern matching. This is a feature which was introduced in JDK 21. You can see that we have nested records in here. You have a record person with name and age, address with string, street and city. We have a contact with person and address. So this contact is having a nested record person, nested record address. Over here we are saying process contact and passing it as an object. We are checking object instance of contact, and inside that we are defining a nested structure: person, var name, var age, address, var street and var city. If the object is instance of contact, if the object which is being passed into this specific method is an instance of contact, then what would happen is that the deconstruction would happen and the values would be assigned to name age, street, and city. So the values inside the contact, the person values and the address values would be deconstructed and directly assigned to these variables: name, age, street, and city. And you can do something like this: system.out.println name lives in city. So what we are talking about is the fact that records are introduced in JDK 21 and the advanced pattern matching is added into records in JDK 21. In this step, we looked at some of the things that you need to be careful with when using records. We talked about the fact that records are immutable. Fields cannot be changed after object creation. If you want mutable state or complex behavior, it's better to use a regular class. Records cannot have instance variables other than those declared in the record header. Records support interfaces but do not support inheritance. You can use records when you want to create a data model or a configuration or a lightweight domain object. It is not recommended to use records for mutable objects or when you have complex business logic or if you want to create an inheritance-based hierarchy. We also looked at simple record pattern matching and also nested record pattern matching. A very important thing to remember is that records are introduced in JDK 16 and advanced pattern matching that we are talking about in here was introduced in JDK 21. Thank you for joining me on this journey through this wonderful Java interview guide. This video is just a sneak peek into what we believe is the world's best Java interview guide. This guide is built from ground up using insights I have gained from conducting over 100 technical interviews. As you have seen, it's practical, focused, and created with your success in mind. Now, what if you want to go deeper? What if you'd want to look at all the 250 interview questions that we have? What if you'd want to access the complete 15 hours of our interview course? If that's the case, we have a special coupon waiting for you. Just head out to the comments or the description to grab the coupon and register for the complete course. Until I see you again, here's Ranga from In 28 Minutes signing off. Keep learning, keep building, and keep enjoying what you do.